Most of us tend to see the world through a relatively narrow lens, focusing on matters of immediate concern, perhaps counting down the weeks of a frigid winter, stressing over the start of a new school year, or daydreaming about life after retirement. Although these events can consume our day-to-day thoughts, they're little more than the blink of an eye in the grand timeline of the cosmos. So, let's take a bold step back and contemplate what lies ahead, not just decades or centuries from now, but over millions, or even trillions, of years. How might our planet, our species, and the very universe itself transform across these vast epochs? One crucial truth about Earth is that every species that has ever called it home has eventually gone extinct. Despite our current mastery over many natural forces, our own fate isn't exempt from this relentless pattern. Catastrophes, whether sparked by human activity or by the universe's ceaseless processes, could someday extinguish us. Asteroid impacts, global pandemics, unstoppable climate shifts, or even the shockwave from a supernova in our cosmic neighborhood, any of these might bring about a cataclysmic mass extinction. But there's also another possibility. Perhaps we'll transcend such dangers by pushing technology to unimaginable heights, eventually harnessing the immense energy of black holes and, astonishingly, finding ways to exist inside them. If that sounds far-fetched, hold on tight. Our future may be even stranger than we can currently conceive. If you're wondering how much time humanity has left, you're not alone. In 1983, an astrophysicist named Brandon Carter developed a provocative idea known as the doomsday argument. It attempts to estimate the future lifespan of humanity based on the assumption that roughly half of all humans who will ever live have already been born, around 60 billion souls so far. If another 60 billion will eventually be born before humanity ends, we might have only about 9,000 years remaining. By those calculations, there's a 95% chance that humanity will vanish by the year 11,000. In cosmic terms, that span barely registers as a flicker of light. Suppose we do manage to survive beyond that window and overcome our biggest threats through scientific progress. Even then, Earth faces a harsh destiny. In roughly 500 million years, the slow escalation of solar heat will transform our planet into a parched desert, forcing evolution into reverse. Large, heat-sensitive creatures will perish, leaving behind insects, hardy bacteria, and species that adapt to subterranean life. Ultimately, our oceans will begin to boil away, creating a scorching hellscape where no refuge remains. This dire outcome arises because the sun itself is gradually getting hotter and brighter, inching towards the final chapters of its life. In about 5 billion years, it will exhaust its hydrogen fuel and start collapsing under its own gravity, sparking a dramatic shift in which it either expands and engulfs the inner planets, or flares and nudges Earth's orbit outward. Either scenario likely spells trouble for any remaining life forms. Eventually, the sun will fade into a white dwarf, marking the end of its luminous reign. Yet the sun's eventual demise is just a small piece of the cosmic jigsaw puzzle. Thanks to the laws of physics, looking deeper into space is akin to peering back in time. We witness distant galaxies not as they are now, but as they were eons ago. An enigmatic force dubbed dark energy appears to be accelerating the expansion of the universe, driving galaxies away from one another at breakneck speeds. Past a certain boundary, an effective event horizon, their light will never reach us again. If intelligent observers exist 3 trillion years from now, they might only see the remnants of our own galaxy, and nothing else. Even the faint glow of the cosmic microwave background, the earliest light in the universe, will fade, erasing the last fingerprint of the Big Bang from view. Our own Milky Way galaxy, however, still has more immediate changes in store. In 2 billion years, it's set to collide with the Andromeda Galaxy, entering a chaotic period of repeated collisions and separations until the two finally merge into a single, larger galaxy, informally nicknamed Milkomeda. The violent merging of galaxies can create new waves of star formation, tear gas and dust into swirling ribbons, and potentially leave behind colossal merged black holes at the center. Surprisingly, Earth might endure that cosmic upheaval, though survival would depend on many factors, including the precise gravitational reshuffling triggered by the collision. Over astronomical timescales, the abundance of star-forming gas will diminish across the cosmos. Brilliant, young stars will give way to dimmer red giants and cooling white dwarfs, eventually morphing into even darker black dwarfs. The night sky, once filled with blazing suns, will go dark as though someone flicked off a universal light switch. If humans, or any intelligent beings, remain alive in that distant era, they'll face an epoch of unrelenting darkness and near-freezing conditions. Against this backdrop, black holes could become prime sources of energy, because these collapsed pockets of space-time convert mass to energy more efficiently than any star. Harnessing that power might be the only way to persist when the rest of the cosmos has dimmed to invisibility. We've long speculated about other intelligent civilizations scattered across the universe, wielding outlandish technologies that dwarf our own. Yet the Fermi paradox points out a stark puzzle. Where is everybody? If advanced extraterrestrials exist, we've neither heard their signals nor seen overt clues of their presence. Explanations vary, from the notion that we're looking in the wrong frequencies to the possibility that higher civilizations prefer non-interference, or that they're so far beyond our technology we wouldn't recognize their transmissions anyway. An intriguing new theory suggests a scenario even more dramatic, that the oldest and most advanced civilizations might have deliberately settled inside ultra-massive black holes, giants tens of times larger than our solar system. These behemoths, some discovered by NASA's Chandra X-ray Observatory, boast event horizons millions or billions of times more massive than the Sun, offering a potentially stable zone near their interior. If conditions are precisely right, entire star systems or advanced artificial habitats could, in theory, exist around the singularity, orbiting like cosmic islands hidden behind a literal curtain of darkness. Russian cosmologist Vyacheslav Dokuchayev has proposed that certain types of rotating and charged black holes, Reissner-Nordstrom black holes, might reduce tidal stresses and radiation enough to permit a habitable zone at the edge of the event horizon. Achieving such an extraordinary feat would require a civilization's technological level to reach at least type 3 on the Kardashev scale, meaning it harnesses energy on the scale of an entire galaxy. By contrast, our human society hasn't yet achieved type 1 status, which is the ability to fully utilize all energy resources on a single planet. If cosmic civilizations have progressed so far that they can hide within black holes, tapping into spinning singularities, capturing orbiting photons for light and heat, and potentially even fabricating pocket universes in labs, our best telescopes and radio arrays might be completely blind to their existence. While the notion of living in or around a black hole may sound outlandish, remember that black holes themselves were once considered purely theoretical. Scientists like the late Stephen Hawking shocked the world by showing that black holes could evaporate slowly via Hawking radiation, releasing energy back into space over incomprehensible timescales. Eventually, even these formidable objects will vanish, leaving behind sparse photons and elementary particles drifting through a universe cooled almost to absolute zero. If dark energy continues accelerating the expansion, these vestiges will be pulled so far apart they'll never recombine. Unless another Big Bang restarts the cycle, the cosmos could end in perpetual cold and darkness, a fate known as the heat death of the universe. Though it may seem grim, this long-view perspective is humbling, as well as awe-inspiring. By reflecting on the distant future, whether it's black hole societies or the total collapse of cosmic order, we develop a deeper appreciation for the here and now. We live in a moment of abundant sunlight, starry nights, and an Earth still flourishing with life. Regardless of how large the cosmos becomes or how it may fade, our ability to reason, learn, and adapt is extraordinary. It's a privilege to be conscious observers at a time when we can still see galaxies in the night sky, study the cosmic background radiation, and speculate about alien civilizations in worlds both near and unimaginably remote. So, as you mull over the unimaginable spans of time and the dizzying possibilities of future existence, take a moment to marvel at the complexity of this universe. Perhaps we'll evolve toward harnessing energies far beyond our wildest dreams, or maybe we'll leave behind only fossilized traces for whoever comes next to discover. Either way, the cosmic story marches on, and we're a vital chapter in its narrative, however short our part may be. Thank you for reading through this extended journey into the far future of Earth and beyond. We'd love to hear your thoughts on these cosmic speculations, so feel free to share your ideas in the comments. And if you enjoyed this exploration of space-time, consider subscribing and activating notifications so you'll be among the first to know when new content arrives. Remember, in a universe of staggering possibilities, staying curious is the best way to embrace the wonders that await us.